Hello everyone. Uh, we know the water sources, those are surface sources, subsurface sources. For surface sources, examples are ponds, lakes, streams, rivers, storage reservoirs, oceans. Okay, oceans we generally not use it for water supplies. Okay, all these things are comes under the raw water surface sources. If you take the subsurface sources, springs, infiltration wells, infiltration galleries, wells, tube wells, all these things are comes under the subsurface sources. Okay, if you just roughly I'm giving the information already you know very well. Water quantity estimation. How do you estimate the water quantity? The quantity of water required for municipal uses for which the water supply scheme has to be designed requires some data. What you have to take the data. First of all, you have to take water consumption rate, that is per capita demand in liters per head per day. Okay, you have to take water consumption rate, that is per capita demand. Second one is population to be served. How much population is there? How many people are living in that particular city or municipality? You have to take those data. Okay. So if you want to find out the quantity, if you want to find out the quantity, Q equal to, you will get per capita demand, per capita demand into population, population. Okay, you will get the total quantity of water. If you see the water consumption rate, it is very difficult to precisely assess the quantity of water demanded by the public, since there are many variable factors affecting water consumption. The various types of water demands are already we have studied. For example, if you take the domestic consumption, the normal range is liters 65 to 300 per flushing system. If you consider the flushing system, you will get the 200 to 230 liters per capita per demand. Without flushing system is 135 liters. Okay. If you see the industrial and commercial demand, public uses, losses, you have to consider all these things into the uh, design. Okay. Next, you should keep it in your mind the fire demand also. So if you want to find out the fire demand, we have different types of empirical formulas. For example, Kuchling formula. Next one is Freeman's formula. Ministry of Urban Development manual formula. So we have different types of formulas. Okay, here few factors are affecting per capita demand. So for example, size of the city. Per capita demand for big cities is generally large as compared to that for smaller towns, as big cities have seaward houses. Okay, so size of the city also important factor. Next, presence of industries. If industries are more, we need to supply more amount of water. Climatic conditions. In the hot summer, the people demand more amount of water. Okay, they need more amount of water. Habits of people and their economic status. So already we have studied all these things, but just roughly um once again giving the information. Pressure in the distribution system, efficiency of water works, administration like leaks in water mains and services, and unauthorized use of water can be kept in a minimum by surveys. Okay. Next one is cost of water, policy of metering and charging methods. Example, few municipalities are charging for water. Okay, they are collecting the taxes. All these things we should keep it in your mind. Next one is fluctuations in rate of demand. If you, how do you find out the fluctuation? Average daily per capita demand is equal to quantity required in 12 months divided by 365 into population. Okay. If you want to find out the average daily per capita demand, average daily per capita demand. Average daily per capita demand is equal to, how do you find this? Quantity required in 12 months quantity required in 12 months okay, um, divided by 365 into population into population. Okay, so if you want to find out the average daily per capita demand, this is a formula for the perspective of any competitive exam. It is very useful. Okay, that is equal to quantity required in 12 months divided by 365 into population. Next one is if you find out the if you want to find out the maximum daily demand, maximum daily demand. How do you find out the maximum daily demand? That is nothing but I will tell you formula. This is also important. Maximum daily demand is equal to how much? 1.8 times of 1.8 times of average daily demand. Average daily demand. Okay, so if you want to find out the maximum daily demand, that will become multiplied with average daily demand multiplied with 1.8. Okay, if you want to find out the maximum hourly demand, maximum hourly demand is equal to how much? 1.5 times of average hourly demand, 1.5 times of average hourly demand. Okay, next you can write it as a maximum 1.5 times of 1.5 times of maximum daily demand maximum daily demand divided by 24 hours. Okay, then you will get maximum hourly demand, or you can write it as a 2.57 times of 2.7 times of average daily demand, average daily demand. Okay, so you can write it as in different variation, or right, like 2.57 times of annual average hourly demand also, average annual hourly demand also 2.7 times, okay, divided by 24. This is 24. Okay, so like this you can write. uh, what is mean by design period? Design period is nothing but the quantity should be worked out with due provision for the estimated requirements of the future. Okay, population forecast or and design period. Population forecast and design period. Here, the quantity should be worked out with due provision for the estimated requirements of the future. The future period for which a provision is made in the water supply scheme is known as the design period. The future period for which a provision is made in the water supply scheme is known as the design period. Okay, design period is estimated based on the different factors. How do you find out the design period? Based on useful life of the component, considering obsolescence, wear and tear, etc. Expandability aspect, anticipated rate of growth of population, including industrial, commercial development, and migration, immigration. Okay, available resources, performance of the system during the initial period. Okay, so all these things we should keep in your mind while design period estimation. Okay, so here population forecasting is the calculation or prediction. It is the calculation or prediction of some future events as a result of a study and analysis of available records or data is the population forecasting. Here we are predicting the future population. Okay, we are predicting the future things and future events. Okay, as a result of study and analysis of available records, whatever we have available data from our past, that we should take, and based on those data we will forecast the future population and future events. That is nothing but population forecasting. Okay, so factors affecting the population growth. What are the factors are affecting for population growth? Design of water supply and sanitation scheme is based on the projected population of a particular city. So if is there is a one municipality, new municipality is there, as an environmental engineer or water supply engineer, what you have to do? You have to design a water supply scheme. How do you design that water supply scheme? Based on projected population of the particular city. Okay, after 10 years or 20 years, how much population may live in that particular city? For that particular population, we have to design the water supply scheme. Next, what are the factors affecting changes in population? Are first one is increasing due to births. Okay, decreasing due to deaths, increasing or decreasing due to migration. These factors are affecting changes in population. Okay, some births, some deaths, and some migration, all these things are involved. So how do you find out the population. Based on different methods, we have different methods to calculate the forecasting methods. Okay, first one is arithmetical increase method, second one is geometrical increase method, third one is incremental increase method, fourth one is decrease rate of growth method, simple graphical method, graphical comparison method, master plan method, appropriate or zoning method, or logistic curve method. So we have 9 varieties of methods involving to forecast the population, but in our syllabus we have only 3 methods, that is arithmetical increase method, geometrical increase method, incremental increase method. Okay, so we have only 3 kinds of methods. Okay, in BTech or in your higher education you will discuss all these things based on your syllabus. Let us take one problem. Okay, first of all, what is meant by arithmetical increase method? In this method, it is based on assumption that the rate of change of population with time is constant. Here you should keep it in your mind. The rate of change of population with time is constant. This method is suitable for large and old city. This method is, it is very important thing. This method is useful for, suitable for only large and old cities which considerably development. It is used for small, average or comparatively new cities. It will give lower population estimate than the actual value. Okay, it will give lower population estimate than the actual value. In this method, the average increase in population per decade is calculated from the past census report. How do you calculate the forecast population? You have to take the past record of the census report. Okay, based on those reports, you should calculate the forecasting population. This increases is added to the present population to find out the population of the next decade. This increases is added to the present population to find out the population of the next decade. Thus, it is assumed that the population is increasing at constant rate. Hence, the population changes with respect to time, that is the rate of change of population with respect to time is constant. The rate of change of population with respect to time is constant in the arithmetical increase method. Therefore, after nth decade, suppose nth decade means fifth, after 2 decades or 3 decades, there will be population is p plus n into c. P plus n into c. Here Pn is nothing but the population after nth decade. Okay, suppose this is 2020. After 2040 you have to find out the population, so it will take 2 decades. 2020 to 30 1 decade, 30 to 40 2 decades. Decade means 10 years. Okay, so you have to take the 2 decades. Then P is represent the population. P present the present population. P is nothing but present population. N is nothing but number of decades. If you take the what we call geometrical increase method, geometrical progression method or geometrical increase method. This method is percentage increase in population from decade to decade is assumed to remain constant. Here we will take the percentage increase in population from decade to decade is assumed to remain constant. Geometric means increase is used to find out the future increment in population. Future increment in the population. Since this method gives higher values, it gives the higher values and hence should be applied for new industrial town at beginning of the development. So this is the best method for the new developing cities. Okay, for only few decades, not for long decades. This method is gives the higher values and hence it should be applied for a new industrial town at the beginning of development for only few decades. If you supposed to take the older cities, arithmetical increase method is best one. Okay. Next one is for new cities, geometrical increase method is best suitable. Okay. For this, you have to take this formula Pn equal to population after n decades, population into 1 plus geometric mean Ig divided by 100 whole power n. N is nothing but number of decades. Okay, where Ig equal to geometric mean percentage, P equal to percentage in population, n equal to number of decades. So you can write it as a different values. Okay, some people like write it as a I only. Okay, if you take the incremental increase method, suitable for an average size town under normal conditions where the growth rate is found to be increasing in order. It is suitable for an average size town under normal condition where the growth rate is found to be in increasing order. Increase in increment is considered for calculating future population. Okay, increase in increment is considered for calculating the future population. The incremental increase is determined for each decade from the past population, and average value is added to the present population along with the average rate of increase. Okay, so here the population after nth decade, this is the formula Pn equal to P plus n into x plus n into n plus 1 by 2 into y. Here x, new thing is x, that is average increase, y equal to incremental increase. Okay, so with this formula you can find out the future population after nth decade. We have different types of method. We don't have any all these things in our syllabus. That is graphical method. Population of last few decades are correctly plotted to suitable scale and graph. So this is the year wise. This is the population in lakhs. Okay, in 1951 there is a 1.25 lakhs. 1961 1. 3 lakhs, like this 1.2, sorry, 1.7 lakhs. So like this the population is showing here. The population curve is smoothly extended for getting future population. This extension should be done carefully and requires proper experience and judgment. So without experience and without proper skill you cannot predict the population. Here the best way of applying this method is to extend the curve by comparing with the population curve of some other similar cities having the similar growth conditions. So this is not accurate method, but based on a few surrounding cities and few previous data, we have to plot the curve. Okay, this is a graphical method. So we have different types of methods: master plan method, logistic curve method. All these things comes in and in the next chapter or in the higher studies. Here you can find out the problem in Excel mode, but I will show you exactly